So, today's topic is pressure garment design. Now, what is pressure garment? Pressure garments generate pressure over body parts. So, these are the kind of garment which will generate pressure, a desired pressure on any part of the body where we want to wear it. Generally, they are elastic tubes, but also they can be made from elastic fabrics. These garments are used for scar management, venous and bone and muscle injury, lymphatic disorders, performance enhancement pressure shocks, especially this is required for the players so as to reduce their fatigue. So, there are many use of such kind of garment, and we need to know how to design such garments. So, the very requirement in a pressure garment would be development and maintenance of the required pressure over a certain period of time. This period of time can vary from person to person depending upon the end use. So, we have to make sure that the garment is capable to develop a certain level of pressure, whatever pressure, target pressure we have, and the pressure should be maintained over a certain period of time, that is depending upon the use. For some use it could be few hours, for some use it could be several hours. Then quick doffing and donning, that it should be easily, one can don it or can doff it. The third important thing is comfortable to the wearer. That wearer should not get rashes or any itching tendency or any bad odor, this should not come. So, and the typical use in some cases could be even 23 hours a day, and even it can go up to months in some cases also. So, the duration of use can be anything from few hours to few days also, and the garment should fulfill all these requirements. But the most important requirement is the pressure that we require. Now, these are certain standards by the Germans, British and CEN, that they have defined the pressure garments depending upon the level of pressure that it generates into light pressure garments, medium, strong and heavy. And the light garments, according to German standards, the pressure will vary between 18 to 21 millimeter Hg. British standard says it is between 14 to 17, CN standard says it is between 10 to 14. So, there is a variation between the standards, but roughly we can say that the lighter pressure garments will be able to generate a pressure between 10 to 20, because 10 is the minimum and here 21 is the maximum, in that range. Mediums are also shown here, 23 to 32, 18 to 34 or 18 to 21. Strong is 34 to 46, 25 to 35 and 25 to 32, and very heavy pressure garments can generate pressure more than 49 millimeter Hg. According to CN, it is between 36 to 46 millimeter Hg. So, this gives us an idea ki what level of pressures are expected and how the garments are classified according to the level of pressure that the garment can generate. Okay. From there, if we go to the next slide, pressure generation principle. Let us look at this. That is how pressure is basically generated. Pressure is due to the generation of transverse force as a result of stretching of the fabric or the stretch fabric following a curved path or must have a curvature. Like it is shown here that the body is the inside cylinder, schematically it is shown, sorry, the body is the outside one, the inside one is the dimension of the garment. It is not that the garment has gone inside, but typically the garment dimension is less than the dimension of the body, which is from here to there, and as a result the garment will compress the body part over which it will be lying, and as a result of this compression, that means there will be some amount of stretch in the garment, because the garment is little smaller in size in compared to the body. So, if we place the garment over the body, which is little bigger in size, the garment will be stretched. That means, the garment or the fabric will be under tension, and because of this tension, this transverse force will be generated. So, tension development will depend what is the level of stretch in the fabric and what is the load elongation property of the fabric, load elongation behavior of the fabric, that is stress strain, or we can say force elongation, because the elongation will decide how much force will be generated in the fabric. So, stretch depends upon how short is the garment circumference with respect to the body circumference, and we define it by a factor called reduction factor, and the reduction factor is circumference of the body minus garment circumference. Garment circumference is less than the body circumference, that is divided by the body circumference and expressed in percentage will be the reduction factor in percentage terms. So, that means whatever pressure garments we have, they will be always little shorter than the body part over which it will be resting. Typically, the reduction factors are 10 to 20%. The reduction factor should vary or should be different with respect to applications and the material that you use. Obviously, ultimately what matters is certain amount of force we have to generate, and the force is a function of the stretch of the fabric. So, therefore, depending upon applications, the force requirement in the fabric may differ, and the force that will be generated while we stretch a fabric depends the material that has been used in making these fabrics. Generally, we use elastic fibers, or in some cases we simply use elastic threads, that is threads which are little, which have some elongations. Suppose it is fine filaments and knitted. The filaments are generally polyester or nylon. These filaments are little more extendable than normal cotton fibers. So, they can be also used. So, if you use them without any elastic fiber, then the force development will be much less. So, in some cases we may use them so that just they sit on the skin or on the body part and generate very light force. So, in many cases we do not use any extra elastic fibers, we simply use the filaments, polyester filament, nylon filament, sometimes they may be textured also, and directly use them, make something and put it on the body. If we want to make it little better, because we have to also see that the garment that we make not only should develop pressure, it should be able to sustain the pressure over a long period of time, that is, pressure should not decay much over time. And the other thing is that recovery part, that when it is not worn, the fabric should be able to recover and it will come back to its original dimensions. So, it is not only the stretching behavior which is important, it is also important that it should be able to recover when the stretch is not there on the garment or on the fabric. That is, when you remove the pressure garment from the body and allow it to relax for a certain period of time, maybe over a day, or suppose you are not going to use it in coming 7 days, then we would expect that the garment should come back to its original dimensions. So, recovery property is also equally important, and hence keeping in mind these two, that is stretch, force required to stretch it, and recovery when stretch is not there. The other thing is the stress decay, that is, when we put it on, the pressure should not gradually decline, or if it declines little bit and then remains stationary. So, these are the important aspects, and keeping in mind these aspects, we have to choose the right materials that we have. The options are not many, because elastic fibers or elastic structures are, there are a few fibers which are elastic in nature. It could be rubber filament, it could be elastomeric fibers. The structure that gives you natural stretch, most of them basically they are knitted structures, and the fibers which have good stretch behavior on its own, they are either nylon or polyester. These two are very popular fibers in this category. So, these are the kind of fibers that we can use, and then we can have different structures, knitted structure, sometimes open structures also can be used, because we can make a stretchable open fabric also. Okay. From there we go to the basic theory of pressure generations, that is, according to Laplace law, the pressure is T by R. This equation is very popular and very well known also, that pressure is related to the tension in the fabric, that whatever is the tension is there, and what is the value of R, small r, that is the radius of the circular body. The body part, if we assume it to be circular, not necessarily that all the body parts are circular, most of them may not be perfectly circle, but for the sake of simplicity we make an assumption that the human body parts are mostly circular in nature, and in that case the Laplace law will be valid, P equal to T by R, or it would be 2 T by small d, where d small d will indicate the diameter Then we go to, if we assume the body shape to be round, then circumference and the radius are related. We all know that C equal to 2 pi r, therefore, r becomes C by 2 pi. So, I can replace what r by this factor C by 2 pi. So, the pressure that develops in Pascal is T by C by 100 into 2 pi, where r is in centimeter or C is also in centimeter. So, centimeter if we want to convert into meter. So, C divided by 100 and then it has to be multiplied here by 2 pi, which is in the denominator. So, ultimately it becomes 200 pi T by C, and that gives you a figure 628.32 T by C. So, pressure in Pascal will be this if the tension is in Newton per meter in the fabric, and C is the circumference in centimeter, because we have chosen C to be in centimeter. So, that is how we can calculate, and if we want to convert this Pascal to millimeter Hg, which is mostly reported in the case of pressure garment, then we must establish a relationship between these two. So, how much it is? There is relationship, but 1 millimeter Hg is 133.322 Pascal, and therefore, if this is in Pascal, we divide it by 133.322, that gives you a figure 4.713 T by C. So, if I want to express the pressure in terms of millimeter Hg, then it becomes 4.713 T by C. Roughly we can say 4.7 into T by C, where T is in Newton per meter and C is in centimeter. All right. From there we go to the some other situation may arise, that there are certain regions of the body part where the body part has double curvature. The many parts of the body actually have, to be very accurate, they will be all having double curvatures, and one of the very common example is the knee area. So, the curvature of the knee, along the knee and around the knee, they are not same, they will be different. Therefore, if we put a fabric or a circular tube over the knee, then the tension that will develop or stretch that will develop, they will be different in the horizontal and vertical directions. If this is my vertical directions, this is my horizontal directions, then the pressure that will develop is P is T h by small r h plus T v by small r v, where v indicates vertical directions and h indicates horizontal directions. So, then you have to take into account the stretch into both the directions in order to know what is the value of pressure that will develop. So, this will be required in some cases, or if we want to be very accurate, then we have to use these equations, and we need to therefore know what is going to be the stretch in the fabric in both the directions. If we know the stretch, then we can find out how much tension is developing in that stretched fabric, which will depend upon the property of the fabric. Now, development of stocking with following pressure profile, this is just an example now. Now, here we are showing the pressure requirement in stocking. So, the pressure profile is shown here. So, this graph that we see, this one, the black line that you see here, this is the requirement of pressure along the leg, starting from ankle to the thigh region. So, what we see here, that in the maximum pressure requirement is there near the ankle, that is this region. Here in this region we need maximum pressure. After that the pressure should gradually reduce, and how it will reduce till we reach the thigh is shown in this diagram. And beyond the ankle, over the feet, the pressure again is declining. If this is the pressure profile that we require for stocking, or for that matter any pressure garment that we use, the question will come, how do I develop a structure which will give me this kind of pressure profile. So, there is a diagram on the right hand side just to show where is the ankle. This is called upper ankle, calf, knee and thigh. Okay. Now, how to go about it, that is what we will be now doing it. Now, what we are doing in this diagram is that we can divide the leg starting from thigh to the feet into 3 regions to start with. That is, one region is the thigh region as shown by this arrow, another region is thigh to knee region, that is this region from here to there, and the third region from here to there is the ankle. So, the entire garment can be divided into 3 regions, and if we assume that the geometry of this region thigh is, this part of the thigh is nearly circular or round, then the corresponding fabric that we need to cover this thigh and develop pressure will look like a rectangle. Similarly, from here to the knee, this region is like a slightly conical, and therefore, thigh to knee, this fabric that we require to cover this region will be little conical in shape. Similarly, we can assume from here to there, that is from knee to the ankle, another piece of fabric which will required, which will look again like conical. So, these are very simplified way to make the case simple, as if the entire part is made of 3 regions, one is perfectly round, the other 2 regions are little conical in nature. The pressure required at different locations have been stated, and we can say, if you look at this diagram, the pressure at the here is 30. So, pressure at the ankle region will be around 25. So, let us say the pressure requirement at the ankle is 25 kilopascal, and with respect to that, the pressure requirement in other regions are stated here. It is 100%. It may not be visible very clearly, but here the maximum is considered to be 100. It is, this region is 70%, here it is 50%, and here it is 40%. That means, the requirement of pressure, whatever it is at the ankle level, this will gradually reduce, and at the knees this should be around 70%. Then from knee, as we go up towards the upper part of the thigh, it comes to 50% of what is required at the ankle, and at the upper thigh region when it ends, the requirement is 40%. Then the pressure should gradually reduce. So, what is we need? A graduated pressure requirement, not that the pressure should be uniform from ankle to the thigh. At the ankle, maximum pressure is required, and as we go up, the pressure requirement will gradually is reducing. That is as per this diagram. So, if the pressure at the ankle is 25 kilopascal, pressure over the knee region is going to be 70% of this. So, it is going to be 17.5 kilopascal, and lower thigh region it is going to be around 12.5, it is 50%, and then upper thigh region is going to be 40%. So, it is going to be around 10 kPa. So, therefore, there is a necessity to produce a stocking which will give maximum pressure 25 kPa near the ankle and a minimum pressure of 10 kPa near in the thigh regions. So, graduated pressure is what is required, and for many circumstances we need not just constant pressure over the limb, we need a graduated pressure. So, pressure from ankle to knee is varying from 25 to 17.5 kilopascal. So, this requirement, these values are based on this graph. So, if I divide the leg into regions ankle to knee, knee to lower thigh to upper thigh, then in different regions the pressure requirements are stated. That is, as I said, that the entire leg has been divided into 3 parts or 3 regions, and each region the pressure requirement has been stated. Now, you see within a region also, in the true case, within a region also the pressure should reduce from 25 to 75, 25 to 17.5, from knee to lower thigh 17.5 to 12.5 kPa. So, there is a graduation. This is what is also should be looked into when we are trying to design how over a certain length the pressure will gradually reduce. We may say the reduction is a uniform reduction. All right. Now, what we are trying to do, that means that if I consider thigh region just as an example, which is perfectly round, and therefore, the thigh circumference and thigh length are shown. The thigh region length is this from here to there, as if the garment which is resting on the thigh is cut and opened up. In that case, this is what is going to be the situations, and if this is the actual thigh circumference and thigh length, the fabric envelope that we will require will be definitely shorter than this, because we need certain amount of stretch to develop. So, fabric length L therefore, has to be less than pi d. So, we can, if I want to cover this thigh region by a piece of fabric, it has to be rectangular in shape, and the length of the fabric, sorry, the circumference of the fabric, if this is your length, or you can say this length, this should be less than the circumference of the thigh, and this can be say the width of the fabric piece. So, width of the fabric piece is going to be whatever is the thigh length, but that means this is equal to this is not going to change, but the length of the fabric which will cover the thigh must be less than pi d. The question that comes, how much should be the reduction in the length of the fabric, so that we can develop the pressure that we require in this region. That means, what is going to be the reduction factor to develop the right pressure, that is what we need to know. What we require therefore, is that what is the fabric that I am going to use. See, if we have 2-3 different fabrics, then we should first know what is the force elongation diagram of the fabric. In this case, it is stretch fabric. So, a typical force elongation diagram of stretch fabric is shown here as a test case. One can choose not just one fabric, one can have 3 fabrics A, B, C and do the same analysis. And now, this force versus elongation diagram is given, and this is the equation which has been fitted to describe the change in force with elongations, and it is a quadratic equations of this form, and the actual equation is stated here. Small e stands for elongation, and look, this is the equation that describes, and these formulas are also given earlier. We are just repeating it again. So, this is what this equation describe the force development with elongations. As the elongation is going increasing, the force is increasing in the fabric and gradually it is leveling off. For a typical elastic fabric, this was the data that was obtained. So, now from here we have to go what from the known value of the tension or strain, that is your E has to be found out, the elongation has to be found out from the quadratic equation. If the F value is given to us, tension in the fabric is equivalent to the force that develops in the fabric. So, the F value, if we know, then we need to know how much elongation is required to develop that much force in the fabric. Once this E is known, the reduction factor ratio can be then found out easily. So, if this is what is important for us, first of all, this equation which will basically characterizing the load elongation diagram of a stretch fabric. From here we have to know how to go about it, that is what the steps are like this. So, let us first go to the calculation part. Here this the part of the leg is shown and the dimensions are also given of different parts, like this is the ankle part, position 1, the ankle is 4th position and that is 20 centimeter, and position 1 is this region as shown it here, the value is 51.5 centimeter. So, I can take 4 readings and one can take 5 readings, 6 readings, it is up to the individual who is designing it. For a we have just taken here just 4 readings, but there is no harm in taking more number of readings. So, if P is this value, we already know. Now, let us say the pressure that we require at the ankle is 25 kPa as per the pressure profile we have already seen. So, pressure required is this. So, I have to develop so much pressure at the ankle region in this region. So, so much of kPa basically means 25,000 Newton per meter square, that is the pressure. C is how much? The circumference of the ankle is only 20 centimeter as given here. So, C is 20 centimeter. So, the required stretch in the fabric, whatever fabric will be placed over the ankle region, how much force we require, that is first we need to know. Force required in the fabric which will be covering the ankle region. So, that is going to be P into C by 628.32, that is 796 Newton per meter, that is what is required there. so much of force must develop, 796 Newton per meter, or this meter indicating the width of the fabric, not the thickness. Now, once that is the force that we require, so I put this value in this quadratic equation. So, this is becomes my known value. I need to know how much elongation is required. So, I have to solve this quadratic equation when the force requirement is known to us. So, this is the equation now. From there we can calculate what is the value of E that we need, and if we solve this equation using Excel sheet, we get a value 20.22 millimeter. That is, if the elongation of this fabric that we have seen earlier, it is elongated 20 millimeter, then this much of force will develop. So, all depends upon the nature of that fabric. So, this is the relationship between Pascal in terms of Newton per meter square. So, 1 Pascal is 1 Newton per meter square, and which is equal to 1 kg per meter second square. Now, fabric elongation we know 20 mm, that is 2 centimeter, ankle circumference is 20 centimeter. So, fabric tube circumference has to be 20 minus 2, that is 18 centimeter. So, it has to be 2 centimeter less. Okay. So, the diameter of the tube on this part is going to be 18 by 2 pi, that is 2.86 centimeter. So, we can find out that the ankle region should have a tube of diameter 2.86 centimeter for the fabric that we have chosen. If the fabrics are different, the load elongation diagram will be different, and therefore, we will end up with some other value. If the fabric is very it is the diagram, suppose the fabric is easy to extend, then we will be needing much more elongation has to be there on the fabric, and therefore, the fabric to diameter in that case has to be less. And if the fabric is such that it takes lot of force to deform it by a certain amount, then less deformation is required. But one important thing also to know is that there is a minimum extensibility that is required if we want to put on a tube over our, let us say, the knee or calf regions. So, there are different ways of, if it is just a tube, the way the tube is on is such that we have to stretch it out and then insert our fit, and then it has to be pulled up. So, a minimum amount of stretching has to be done in simply just to push the fit into it and then pull it, so that we can wear it easily. If that stretching is too difficult, I need lot of force to stretch it, because a minimum stretch is required in order to insert the fit. If that stretch itself is so difficult for us, then that will also not be a good kind of design, because then it will give you discomfort during wearing process. So, if the requirement is such that I need high force, but I do not have a fabric which can give that high force, and the same time can be stretched to the extent that the fit can be inserted easily, sometime that could be a clash. That is, that these two requirements may be conflicting to each other. In that case, we have to think of an alternative type of design, where the wearing of this stocking should not be from fit towards the thigh, but it has to be in a different manner. We can have a cut at the middle, and it can be simply placed over the region of the body, and there has to be some other arrangement to tighten it using velcro type of some fastening devices or something else like that we have to think of. Not necessarily that wearing something just near the knee, not necessarily one has to pass the garment through the fit and then reach the knee. We can have some other design also where directly it can be attached to the knee, and we can also have some other type of attachment, so that the fabric can be stretched, and in that stretching conditions we can really fix it around the knee. So, there are different types of designing which is possible, and this is just one simple example that we are showing it. So, whatever we have done for the ankle region, we can do it for the other regions also, calf, knee, upper thigh, and then we can get the size of the fabric pieces, and then we can join them together by some stitching technology or some other joining techniques, and make the garment which will give us a desired pressure. So, based on this, prototypes can be designed, and one can then try it out and see what are the difficulties that we are facing, or whether is it possible to directly knit a fabric tube of required dimensions with elastic threads, which will develop the right amount of pressure. That it could be a seamless type of garment can also be thought of by the use of knitting technology, or if you want to that we can use the fabrics, woven fabrics. Then we have to cut the fabric into different sizes and then join them together. So, this is how one can go about. There are many things about the pressure garment design. It is not that everything has been covered here, not true. There are other aspects as well we have to think of. Designing just does not mean to meeting one requirement only. Here what has been done is that we are trying to meet the requirement of pressure, but then we have to also see that the product should be breathable. Otherwise, if something is worn for a long period of time, the moisture will accumulate. If the moisture accumulates, then sweating may start, especially in summer time. So, we have to tackle that also. Sweat should not be allowed to accumulate. So, we have to think of what we can do, so that the moisture that the skin is continually generating, how to either to take it out by some means, either through absorption or by allowing it to move out to the outside atmosphere. Then the fabric has to be soft also, depending upon where it is placed. The seam that we use in joining the fabric, the seam also, the seam threads should be soft, otherwise it will give you a lot of discomfort as well. If so, we have to take into account the joining techniques, the kind of seam to be used, and the thread to be used to join them together, the selection of fabric. Other than meeting the stretch requirement, we have to also see from the point of view of moisture vapor transmissions. Then the fabric can also lead to discomfort because of the heat entrapment. The body heat has to also escape, otherwise the heat will accumulate and discomfort will start. Accumulation of heat will lead to development of sweat. That means that this garment should also be seen from the angle of thermal insulation value of this. In winter it may be beneficial if there is insulation, for summer it could be, it could create problem, because in summer we do not need insulations, we need the body heat to escape. So, there are other angles also one has to take care while he is trying to design anything for that matter, which is a wearable product. Continually we have to think of, other than meeting the primary requirements, there are other secondary requirements which are equally important, because if you do not meet them, the product is not going to sell, people will reject it after some time. Any itching tendency, any other discomfort, people will say no, 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 this is not a good product. Okay, with this we close this particular session and we meet it again in the next class. Thank you.